Hey everyone, DATS part 2, parameter management. So we're going to look at table DAT and our old friend the select DAT also. So let's just see the system here. I've got a little audio analysis coming in. So this is my microphone in, and we're going to trigger certain parameters based on audio peaks. Okay, cool. So at the core, and actually if that's doing that while I'm talking, that's going to be super annoying. So let's just increase that threshold. Okay. So at its core is a table DAT right here, and which we can manually add rows and columns and add little labels here. So I have 4 different parameters that I am changing. And then I don't have like a label for these, but essentially column 1, 2, and 3 would be 3 different states, or 3 different modes or stages or phases or whatever you want to think of it like. And then I've got the select dat again. So this time I'm selecting a different column because that has the different sort of states I want. And then null dat. And this time I am converting it to a chop with the dat2 chop. So there's a little kind of weirdness there that we need to cover. Rename again to just give it a names that make sense for what they're going to do. A lag. So these things lag and also filter chop are really great for smoothing out changes in data, which we're going to see. And then a null again, and then you can just see. So I've got the normal like banana transform here. So I've got tx parameter going right there. I've got the scale parameter going to the x and y down here. Level top is getting the brightness value right there, and then the hue saturation value adjust is changing the hue offset. So this goes from 0 to 360 for hue. So multiple channels, all kind of changing at once, and then sending those from a single chop to several different operators to do different things. And then for the audio, for the triggering part up here, analyze is something we'll talk about more specifically when we get into sound analysis in a couple of weeks, I think. Audio coming in from my mic, analyze, chop. I think by default it's set to average, but I have it on maximum here. And so if we get a trail chop, this is always helpful to, let me just show that. Also, by the way, these little bullseye thingies, we'll turn that off. It's actually, it kind of optimizes it, so it doesn't actually have to write that data. So here's the trail. So we can see the maximum value coming in. Okay, cool. We'll talk more about this later, like what all these other things mean. Lots of really cool stuff you could do. The operator snippets up in help is great also for the analyze chop, just to kind of learn what all these things do. So what I want to do is I want the banana to change states whenever this number goes above a certain threshold. So this trigger is going to be triggered above a certain threshold. So as it is now, like talking normally, sometimes I get up above 0.1. Check, 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 check. So it's going into trigger. The trigger threshold is now 0.8. I think before I had a 0.2 maybe. Let's try 0.5. So whenever it goes above 0.5 now, this is going to be triggered. There we go. So count has something like that. I could automatically, so if we go count, we learned about that in the last part. It has its own trigger threshold thing here. If I do like 0.5. There we go. So that's working. So I don't really need this trigger chop. I wanted to put it, I'll talk more, I'll do a totally separate video with this too because it's so useful. But sometimes it's nice, let's say, so this is in charge of being triggered. It sends that 0 to 1 pulse to count. But then it's nice to have a triggers maybe I want to send just like a 0 to 1 pulse somewhere else. And maybe there's some other things that are synchronized with the banana moving around. Maybe something flashes or whatever. I don't know. So this would be a kind of central triggering thing which affects the count and something else. So it's just also kind of like as you do this more, you start to think ahead and think of possibilities, and you kind of go ahead and make life easy for yourself. What we're doing, it would be fine just to use the count and not a trigger. But whatever, I'll just keep that right there. So let's take that back to 0, and 0.5 is just fine. We'll talk in different videos about, we've got attack, peak, decay, sustained, release values. So if you're familiar with audio envelopes, ADSR envelopes, attack, decay, sustain, release, that's basically what trigger chop does. So we can contour our data, our triggers in various ways. Okay, so I'm doing this same as before. I've got kind of looping here. In this case, I'm looping through columns. So I'm looking at, okay, how many different kind of state columns do I have here? So I grabbed table 2, num calls -1. That's giving me this looping 1 to 3. Great. And same thing here. So on my select, I'm selecting columns assigned by index. And in the end call, I am doing me.par.call index start, because that's what this one is called. And then the start is what's actually getting the reference up here. And then also you can see, okay, so I'm cycling through these. So the DAT2, let's go ahead and get one of those. So we can just select which DAT we're bringing in there. So drag that. Great. And so by default, you can see this is like a really weird thing because, okay, so we have to look at output, first row, first columns. So we're going to output a different channel per row, which is what we want to do, right? So these are 4 different rows. I want to have 4 different channels in my chop, so that is correct. You know, if it's structured in different ways, we can do different things there, but that's correct. First row is values, so that's correct. So we don't have any more labels here, no names. It's just pure just values, right? So first row is values, that is correct. First column is names, so that's what's making a problem here for us, because we could so okay, there's different ways we can do this. So first column, actually we don't have any names left in this, right? So if that's values, then that gives us the proper thing here, right? And then because there are no names in this, it just generates the names like Chan 1 2 3 4, and then we had to do the separate rename right here. Let me show you a different way that we could have done that, is to like maintain this thing right here. So maybe easiest way to show this, let's do another select. For this one, we're going to do, we'll do just manual. Oops, not 12. No, 1. Okay, great. Or no, I mean 0. That's what I meant. Okay, so I'm just grabbing column 0 with the names, and here's doing the selecting of one of these parameter states, and I'm going to get a merge and append columns. There we go, and then I can switch that around. Great. Okay, there we go. So now I've kind of maintained my little labels here by doing 2 different selects and then merging them back together. And so now in my DAT2, I could do something like, so first column now is names. Okay. So now I'm grabbing the names directly from here, and I don't have to do a separate rename up here. It's, I mean, whatever. It's not that much work, but just to show that, you know, depending on what the data is, you need to just be aware of how you have your settings right there. So that's right. Maybe it's like a little extra work right here. Whatever. It doesn't really matter. So I'll just keep this here for now. Sorry, this is redundant now, but whatever. So we're going through rename. So let's just turn off lag for a second. So this little bypass, we haven't talked about too much, but click that, and now nothing is going to be processed by this operator. look at that. It just jumps. There's no tweening in between. Because essentially, right, these values are kind of like if we think about After Effects world or something with keyframes, these are just keyframe values, right? And it's just like jumping from one value to the next and then going to the parameters here. What lag does is it lags the value. So let's see. Actually, we can see also. Let's get another trail so we can kind of see. So by default, so it's got two different values for when the values are increasing and when the values are decreasing. So you can have separate, it's almost like also in kind of modular synth world, like a slew, rise and fall. So kind of slowing down, increasing values, slowing down, decreasing values. So just by default, 0.2 seconds on each. So now you can kind of see how that changes. It's got that little hump. Okay, but I haven't actually connected that yet, so let's actually do that one. There we go. That's a quick one. And then we can play around with, make this longer or shorter or whatever. These values are, let's do that. Let's do 1. So it adds a little different vibe to it, right? Because you can see some of these values are going down and some are going up. So therefore, they will have different lag times. So that all went up. That all went down. There we go. So on this final one, the TX went down, the other ones went up. So it kind of changes the behavior a little bit. And then Overshoot is kind of fun. It'll kind of go beyond where it's supposed to go and then kind of come back like a spring. So let's actually make this the same. We'll try 0.5 for each of these, and then let's overshoot 0.2. You see that? Let's do a little bit more, actually. Another thing I showed before, the value ladder, middle mouse click to kind of change that. In this situation, if you have a parameter that has multiple fields, in this case for rising or falling values, sometimes you might see for like a TX, TY, TZ, something like that, I could middle click on the actual name and get that value ladder, and then it'll change all of them. Let's actually want those to be the same though. So let's do overshoot, maybe 0.5. Oh, there we go. See? It goes too far and then comes back. It's like a spring. And it kind of lands on where it's supposed to be. So overshoot is a cool thing. These other things, you can look some more into it if you'd like. I don't use these as much, but so lag is super helpful in a chop thread to kind of tween between values or smooth things out. Another one that does something like that is the filter. Let's go ahead and get a filter chop. And let's see what's happening there. So by default, filter width 1 second. So it doesn't have rising and falling differences, but so the shape of the curve differs from lag. You can kind of see there. I pause this for a second. It's got to kind of ease in and ease out. So just depending on just the contours of that data, how you want the parameters to get it, you might use lag or filter interchangeably, just to specify that exact contour. Cool. No overshoot for filter though. Okay, let's keep the lag. And that's it, right? So all this other stuff is just plain old chop references that we are comfortable with now. But we can maybe I'll point out one more little trick with references though. Because we're starting to hopefully be more aware of the actual Python stuff that gets written here, and what that means. So by default, it's going to list the channel name for the chop that it's getting the reference from. What if, let's say a common situation might be, let's say the started as like Chan 1 2 3 4, and we did the reference, and then later we added this rename. We're like, oh, I want to actually give them names, and so now instead of Chan 1 2 3 4, they're named TX Scale Bright Hue. This is going to give you an error because this is looking for the original name that it had when you first referenced it. If you change the channel name, then you're going to get a problem. So case in point, whatever, dog. Right, so now this gives me an error. Right, it's still looking for a channel called TX, and there's no channel called TX because I changed it. So a different way to do this, just a different way to be aware of how data is stored in this. Instead of referencing the name of that channel, I could do something like this. So this is the channel index, which means 0 is the first channel, so which is TX. 1 is the second channel, which would be scale. So sometimes this makes sense, sometimes not. You know, it's kind of nice if you kind of look at this. If I could see a channel name, then it helps to identify it a little bit better. Other times you might have dynamic channel names for some reason. This is a little more secure. Or maybe sometime you've got like a merge happening and channels get rearranged or shuffled in different ways. So sometimes you want to grab the certain name, sometimes you want to grab like whatever the first channel is. So as you work, you'll kind of understand other cases like that, but just to show that this would be another way to do the same thing. Usually you're fine just keeping it default and having the channel name in there though. Okay, I think that's good for part 2. Oh, actually, here's another little part. I wanted to show a real-world example of exactly this thing. I use this idea of using a table DAT to store parameter states all the time. So this is a project that I did last year. This is in a show in Alaska right now in a museum. But essentially, I have lots of these little geometric shapes that are created essentially in the intro to SOP's videos. At one point I showed the twist SOP. So I've got a pretty simple like wireframe geometry coming in, and then it's getting all these different kind of twist operations done on it, which is creating all these different shapes. And I wanted to randomize that somehow and have control over all those, like exactly what those parameters are. A lot of times with the twist SOP, you know, there's a sweet spot in like from point 1 to point 2, and you get too much in one direction and it kind of just looks terrible. So they were like very specific parameter values that I wanted. And so what I did was, if you go into here, we've got a whole lot of stuff happening there. This table 1 right here, this is storing all of my states. And I've got lots of columns here, so if I just kind of click this, then we get a little scroll bar. So we can see here's just a little name of parameters that these eventually go to a number of different operators. Some of these at the bottom here, so these are the twist SOP. Some are go to like the camera comp, some go to the geo comp. And then each column would be a different state. So if we go across, I think I have like 30 states essentially. So that's same as what I just showed, just to kind of a lot more cells of data. And so for each of those little geometric things, it's grabbing one of these columns and applying all these values to certain operators. So doing the same sort of like select here, just select a certain column, and that's same as what I just showed. A more kind of advanced, looking forward to the future, where I will do videos about the execute stats, specifically the chop executes, is one of the most useful ones, I think. You might look at this table DAT and think, like, oh my God, how to even fill that? That seems like a whole lot of work, which normally, Actually, I just realized I didn't actually show this in the other one. If we go to table, how you actually do that. If we hit parameter exact dimensions, turn that on, and then we can create however many rows and columns we want. And then to actually type in here, click plus, and then usually it's kind of nice to add a little label. So I don't know, do like hue, and hit tab to kind of cycle through these quickly. Whatever. Okay, so give it a name, and then you would kind of play around with the actual operators, find the exact values that you want for those, and then go ahead and just write those values in, whatever. Right, and then say, oh, I want to add like extra states, so you can just add extra columns there. You could do this a different way. We could have the name of the parameters at the top row, and then just add new rows for each state. Doesn't matter. So whatever way you do it, just like know that with your select dat and for the references down the road, you have to do that. So that's manually putting in values that you're going to use somewhere. For this one, it was all written by this chop execute dat. So what I did was, I think I was playing around with all these different operators. This constant is sort of reading all the parameters that I'm kind of paying attention to. And if I found, okay, this I want to create a preset. Like this is exactly all these different values. This is what I want. Click this little button. So this also is coming up in future weeks using this UI elements like buttons and sliders and things. So we click that. That triggers, this basically goes from 0 to 1 when I click this button. And then this is a little Python here, which grabs all those values. And so this little line here, so append column to table 1. So this is another one of those things that we can find out if I click table 1 here. So by clicking on this little Python help, one of the methods that it describes is this append column and all the things that it requires of how you can actually create rows, create columns, fill it with content, shift around content with Python scripts. So that is how that is happening. So that's how I filled all of these values fairly quickly without having to manually type all these numbers. Okay, cool.